the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siya. Kubeka, let's learn the new way. Siyahamba phezulu. Daily dose of power. AI's here. Siya. Kubeka, let's learn the new way. Siyahamba phezulu.
Hi guys, welcome to another lesson of the Daily Dose of Mathematics. In our lesson today, we're going to be doing the whole of 4.2 of the June 2026 Limpopo question paper. Now, if you stick with us up until the end, guys, we're also going to be using a new prompt, which we call scaffolding, at the end with the last question. How does the prompt work? It's going to give us a similar question, and then it's going to solve the similar question so that we know how should we approach our question. Let's take it. We're starting with 4.2.1.
Yeah.
Okay. What is 4.2.1?
So the 4.2.1 says we shall calculate the coordinates of the x-intercept of the graph of f.
Okay, let's check. What is f?
So then our f of x is given as x squared minus 2x.
It's x squared minus 2x.
Minus 3.
Minus 3. Okay, what kind of a function is this one?
Oh, this one is a parabolic function.
It's a parabolic function. Yeah? So basically, we're back to question 1. We're solving the first question, which is 1.1.1.
Yeah.
And then the first question says you should calculate one. Let's
the
write
coordinates of x-intercept.
4.2.1.
Yeah.
Okay. Calculate the x-intercept.
Yeah.
So we're calculating the x-intercept. Now, Ghana, for us to calculate the x-intercept, what should happen?
Y should be equal to 0.
So we're calculating at the line where y is equal to 0.
Yeah.
So we're going to tell them that 0 is equal to, instead of f of x, we put 0.
Yeah.
So we have x squared minus 2x.
X squared minus 2x.
Minus 3.
Minus 3.
Yeah, from here onwards, guys, you can try to factorize this one. Or if you don't know how to factorize, I will show you a new way of how to, if you don't know how to factorize, there's another tricky way in which you can do using your calculator. But it's going to take a little bit of understanding, but we'll see it. Okay, let's open two brackets here. If you open two brackets,
0 is equal to first bracket with x.
Yeah, we put x and then we also put x.
Yeah.
Okay. Now we're looking for factors of 3.
Yeah.
When we multiply them, they should give us 3, but when we add or subtract, they should give us minus 2.
Minus 2.
Yeah, in this case, they are going to be straightforward. It's minus 3, which goes with plus 1.
Goes with plus 1.
Okay. So I'm going to tell them that x is going to be equal to 3.
Yeah.
Or x is going to be equal to what? Minus 1.
To minus 1.
Sure. And then how many marks is this question?
This question is 2 marks.
It's 2 marks. So they're going to give us 1 mark for factorizing and 1 mark for both answers. What was the question? Let's check the question exactly. What did it say?
It says calculate the coordinates of the x-intercept.
Yeah, so we need to write it in a coordinate form because they didn't say just calculate the rules. They said calculate the coordinate. So you're not done. You should tell them that when x is equaling to 3,
y is equal to 0.
It's equal to 0. Yeah, that's the first point that we have. The first coordinate. The second one, it says when x is equaling to minus 1.
Negative 1.
Minus 1, yeah.
Or y is equal to 0.
Or y is equal to 0. Sure. Okay, we're done with that first part.
Yeah.
Now, what we're going to do, guys, remember you're at the Daily Dose of Mathematics. We're going to be dancing a little bit here before we go to our next question. But before we do that, we're going to take the question, put it on a senior marker. Let's put our dance song first before we do that.
Let's go. We looking at the curves today. The parabola path. Are we smiling? Are we frowning? Let's find the intercepts. Let's find the turn. Let's go. Standard form is here. X22BX pitch you see. The quadratic function. Keep your vision free. You want the x-intercepts. Then hear me say, set y to 0, that's the only way. Fancy. So for x, find the roots, let the numbers play. But don't forget the y-intercepts. Do it today. Set x to 0, look at C. It's plain to see. That's where the graph cuts the axis perfectly. Oh, the turning point, the vertex of the line. Where the curves start shifting, looking so fine. Use the formula over 2a. Get the x coordinate, it's not far away. Take that value, put it back in. Get the y coordinate, solve the complex. Or take the derivative, set it to 0, yes. Find the turning point, positive, then we're smiling wide. A minimum point with the shape on our side is a negative, then we're frowning, it's true.
Final grade,
peak,
2
that's
halves.
what we do.
Final answer, 3, 0, and -1, 0, caps marking audit. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. Factorization 0 equals x3, x plus 1, checkmark A. Accurate factorization of the quadratic trinomial. Coordinates, 3, 0, and -1, 0, checkmark CA. Consistent accuracy for solving for x and writing the final answers in correct coordinate format. 2. Corrective feedback. You're working in image_88b150 link to .png is flawless. You successfully factorized the quadratic equation by finding the correct factors of -3 that sum to -2, which you smartly noted in green on the side. You then correctly solved for x and translated those values into the final coordinates. There are no logical flaws to address. 3. Caps and formal notation compliance. Terminology. You correctly applied the core concept of an x-intercept by setting the output of the function to 0. Notation. You perfectly executed the South African caps notation standard by using semicolons in your coordinates 3, 0, and -1, 0. This avoids any confusion with decimal commas, e.g., 3, 0, and secures your final presentation mark. 4. Coach's summary. What you did well. You paid close attention to the specific wording of the prompt. The question asked for the coordinates, and you explicitly provided them at the bottom. A very common trap for matric students is to stop at x equals 3, text, or x equals -1 and lose the final mark. Area for improvement. While starting with 0 equals x squared 2x3 is perfectly mathematically sound, it is excellent exam technique to write a brief declaration statement like, let y equals 0, or let f, x, equals 0 inches on the very first line before substituting. This leaves absolutely zero ambiguity for the marker regarding your method.
Okay, guys, now we're going to continue with 4.2.2. No?
Yeah.
And then remember, guys, get your notebook, get your calculator, and then get your dancing shoes on. Let's go to 4.2.2.
So on 4.2.2, they said we should calculate the coordinates of the turning point of the graph of f.
Okay, we're supposed to calculate the coordinates of the turning point. No?
Yeah.
Now, personally, guys, I will say I prefer, if we're talking about the turning point, we are referring to the minimum or the maximum. No? Now, personally, I will say because you are in grade 12, you already know about differentiation. It will be best if you use differentiation of calculus because with the derivative, it works when you are dealing with cubics and then when you're also dealing with parabolic function. Because the formula, this one, let's write the formula that we usually use in grade 11. It says x is equal to minus b.
X is equal to minus b.
All over 2a.
All over 2a.
Yeah, you can use this formula. It doesn't work on a cubic function. It can only work if you are dealing with a parabolic function. Then the mistake that I've seen with learners, they want to also use it when they say turning point on a cubic function. They also want to use this formula. So to avoid that, I would say, learners, let's differentiate. Every time when they say turning point, let's differentiate. So we have f of x.
Yeah.
Is equal to
f of x
squared.
Is equal to x squared.
Minus 2x.
Minus 2x.
Minus 3.
Minus 3.
Then we're going to tell them f prime of x, we're differentiating.
F prime of x.
Now we say 2 multiplied by 1, which is the coefficient in front of x.
Yeah.
So we have 2x, and then we say 2 minus 1, and then we get 1 as the exponent.
Yeah.
Yeah, and then with this other one, we're going to have minus, we are going to have 1 multiplied by 2. Okay?
Yeah.
And then after that, we say 1 minus 1, it gives us x to the power of 0.
Yeah.
Which is going to be equaling to 2. Now, only do this if you are comfortable with differentiation. So after that, we've differentiated.
Yeah.
We have 0, which is going to be equaling to 2x minus 2.
2x minus 2.
Yeah. Now, we are going to take the minus 2 to the other side.
The other side is going to affect its sign and become positive.
Yeah, so we're going to have 2, which is going to be equal to 2x. Huh?
Yeah, 2 is equal to 2x.
We divide both sides by 2. What does it say?
So then our x is equal to 1.
So we have x is equal to 1. The question said we should calculate the coordinates of the turning point.
Yeah.
So we're not done. We just got the x value here. Now, after getting the x value, let's just show them. We're going to take this value and substitute it on f of x. Remember, guys, if you substitute it on f prime of x, you're going to get m. F prime of x gives you m, doesn't give you y. Ne?
Yeah.
So, Tina, mind you, we want to know, actually, x is 1. Ne?
Yeah.
What is our y value? That's what we're interested in. So, we're going to say f of 1. Instead of x, now we're going to put 1.
Yeah.
Which is going to be equal to
open bracket
1
all squared
sharp
minus 2 open bracket 1 close bracket minus 3.
Yeah.
Then
So
yes.
if you are not comfortable, you can try to do this, because if you say 1 squared, it gives you 1 again.
Yeah.
And then you say minus 2 multiplied by 1, it gives you minus 2.
Yeah.
And then we have minus 3.
Yeah.
Now you can add this thing up. You can clearly see that you have minus 2, which goes with minus 3 again.
Yeah.
It gives you minus 5. And then you have plus 1, which is going to give you what? Minus 4. But if you're not comfortable, you can just type this exactly the way it is on your calculator.
Calculator says it's minus 4.
It says it's minus 4.
So then our f of 1 is minus 4.
Yeah, so we're going to tell them when x is equal to minus 1, our y is what?
Our y, when our x is 1.
Oh, our x is 1. Yeah, our x is 1. Sorry.
Our y is negative 4.
Our x is negative 4, sure. Okay, we are done with this part, guys. We're dancing again. Let's go back to our song, and then we put this in a senior marker. Remember, guys, why do we put these things on a senior marker? We're trying to encourage you to say that if you are working alone at home, you should have this prompt so that you can also put your working on the AI so that it can grade you, so that you can see your mistakes before you go to an examination. Let's start with the song first.
Okay, let me copy the question first, and then we'll go to the song thing. Let's dance, guys. You know, dancing is one of our favorite things in the world. Use the Amapiano dance style and cream your mates. That's the way it works. And don't forget.
And symmetry, baby, it's the heart of the core. The turning point is the middle, that's what it's for. Halfway between the intercepts, the axis of the line. It splits the parabola, everything aligned. When you look at the sketch, check where the graph goes. Below the x-axis, that's where the inequality flows. And if you need a tangent at the turning point height, it's a horizontal line, shining so bright. Yeah, that's the constant glow. Parabola secrets, now you're in the know. Oh, the turning point, the vertex of the line. Where the curves start shifting, looking so fine. Use the formula over 2a. Get the x coordinate, it's not far away.
Final grade, 2 halves. Final answer, 1, minus 4, caps marking audit. 1, marking breakdown. Step. Working shown. Mark allocation. Justification x coordinate f, x, equals 2x2. 0 equals 2x2. X equals 1. Check mark A. Accurate differentiation using the power rule and equating to 0 to find the x value of the stationary point. Y coordinate and final answer f, 1, equals 1, squared 2, 1, 3. F, 1, equals minus 4, 1, minus 4, check mark CA. Consistent accuracy in substitution and presenting the final answer in the correct coordinate format. 2. Corrective feedback. Your calculation in image_890 FFE link to .png is perfectly executed. Using the calculus method, first derivative, to find the turning point of a parabola is highly efficient and perfectly acceptable in grade 12. Your algebraic transposition to solve for x and subsequent substitution are flawless. There are no logical flaws to address. 3. Caps and formal notation compliance. Terminology. You correctly utilized the f(x) notation for the first derivative and the f(1) notation to show substitution into the original function. Notation. Because you applied the power rules of differentiation rather than calculating from first principles, limit notation, lim_h, to 0, is not required here. Your use of the standard derivative notation is perfectly compliant. You successfully used the strict semicolon notation for the coordinate 1, minus 4, which is exactly what examiners look for to award the final presentation mark. 4. Coach's summary. What you did well. Crossing out the original function equation f, x, equals x squared 2x3 once you had written it down is a great self-management technique to ensure you don't accidentally substitute back into it prematurely, while keeping your derivative work cleanly separated directly underneath. Area for improvement. Before jumping straight from f, x, equals 2x2 to 0 equals 2x2, add a brief formal statement. For turning point, let f, x, equals O. This clearly communicates your mathematical theory to the examiner and locks in your method marks immediately.
Okay, guys, we are moving on to 4.2.3. Let's go to our next question.
So our next question says, draw a sketch of f, indicate the turning points and the intercept or with the axis on the sketch.
Okay, so we're supposed to draw the following. Now we have a graph paper. Usually they provide the graph paper in the final examination. So it's something that you shouldn't worry about. Now, if you are not sure, let's say you want, because I usually say to learners, there's no need for you, if they say draw, those are free marks, you should make sure that you get those marks. So we are going to draw the graph, and then we're also going to show you how to use your calculator to get the shape of the graph if you are not sure how the shape should look like. Okay, let's go there. We have our graph paper.
Yeah.
Okay, now I have graph paper. We are going to start by shading on the x-intercept. Remember, we got our x-intercept as -1 and 3.
-1 and 3.
Okay, let's go and say we're opening a gate here. This is where the graph is going to pass. We're giving it permission. This is where it's supposed to pass. So you can just press an X there and say this is where the graph is passing. Okay, next we have X is 3.
Yeah.
We're also going to say the graph is also going to pass here.
Yeah.
And then the other one that we didn't calculate is the y-intercept. But the y-intercept is whatever the value of C is. So what is our value of C in this case? Let's check.
So then our value of C is -3.
It's -2. So I'm going to tell them when x is equal to 0, our y is equal to -3.
Yeah.
So we go down here on the y-axis, and then we say this is the gate for the y-axis. This is where the graph is supposed to pass.
Okay.
Yeah. Okay. And then after doing that, now the last thing that we have to plot is the coordinates of the turning points. Yeah. So it says when x is 1.
Yeah.
So we just draw dotted line on 1. We go down, we go down, we go down, we go down. And then we say our y should be -4.
Yeah.
So where the two meet, you are going to highlight to say this is where we're going to be drawing our graph. Okay. Now, if you are not sure with the shape now, guys, it's simple. Then the graph, because they say this one is a turning point. Okay?
Yeah.
So your graph can either turn and look downwards, or it can turn and look upwards. Okay?
Yeah.
But you can see if your graph turns and look downwards, there's no one to go to. Even.
Yeah.
So it's clear that the graph should look upwards. And then also the value of A told us, because it's positive, our graph is going to be smiling.
Yeah.
So now let's plot. We're going to say we have, starting from the top, we go to -1.
Yeah.
Okay, sharp. It's fine.
Yeah.
Okay, after that we go to -3.
Yep.
Okay, from -3 we are going to go to the turning point.
Yeah.
This is where our graph, it passes through -3, it's a gate, and then it turns here.
Yeah.
Okay, now it goes up, it goes to 3.
Yes.
And then we just put an arrow to say that it continues. After that, you just draw a line and then say it continues. It shouldn't be a straight line, it's a curve.
Yeah, it's a curve.
Yeah, so we just put arrows to say that this graph is going to continue forever.
Yeah.
Now, let's show you, if you wanted to use your calculator to get, you can use the calculator to get the x-intercept and also to get the shape. That is why I was saying to learners, for learners who are still not comfortable with factorizing, let's go to the calculator. On the calculator, we're going to press mode.
Mode.
Yeah, okay. You have which option? Option number 1 is what?
It's compute.
Comp. Comp is the one that you normally use.
Yeah.
Option 2?
It's complex.
Option 3?
Stats.
Option 4?
Base in.
Option 5?
Equality.
The next option?
Matrix.
The next one?
Is table.
Yeah, let's use table. Now, depending on where do you find table on your calculator, guys. So in this one, we find it on option 5.
Yeah.
So you press 5. It says f of x.
Yeah.
Okay, you're going to type this thing exactly the way it is. We're going to show you how to type it on your calculator. So it says f of x.
Yeah.
It's going to be equaling to. Now, you're going to put,
X.
yeah, how do you put X? You say alpha, no?
Shift. You say shift.
Yeah.
Then you say open bracket. Oh, you say close bracket. Then it's gonna give you. Oh, is it supposed to be alpha? Yeah, it's alpha. It's alpha.
Yeah, you say alpha and then you press X.
Close bracket, yeah. And then you say all squared minus 2
Yeah.
alpha
X, yeah.
X minus 3.
Minus 3, yeah.
Then it's gonna give you
Yeah, so what is the next step? It says what?
it says you have g of x.
Okay, we don't have g of x in this case. What else should we do after that? They say what?
Enter, and then it says where does it start?
Yeah, so you want your graph to start, you're looking at the value of C. Usually you just check the value of C. You want your graph to start in between the value of C. No?
Yeah.
So I'm going to say, let it start at -4. So I'm going to say -4.
Let it start at -4.
And then they're going to ask us, where is it going to end? We're going to tell them, let it end at 4.
4.
Yeah.
And then step 1.
Yeah, so the step was just going to tell them that our step should be 1. You can change your step to be 0.5. You can change your step to be 1. The basic one, it's 1.
Yeah.
So let's leave it as 1. And then you say equals 2. No?
Yeah. It gives you that -4 goes with 21.
Yeah, so if you check this one here, you could plot this thing here on your graph paper and then just connect the dots, starting from the first one to the second one. Now, the thing that I'm interested in here is that learners can also get factors. No?
Yeah.
Go and look at the f of x. Can you see the f of x side? Okay?
Yeah.
Go and check f of x. You are going to go down on f of x, f of x, f of x, and then you're going to check where f of x is 0. No?
Yeah.
Check f of x is 0.
When f of x is 0, our x is -1.
Yeah, so I'm going to tell them with x is equal to -1. So if you didn't know how to factorize, you could use the table.
Yeah.
From using the table, you look at where f of x is equal to 0. After seeing f of x is equal to 0, then you check what is the corresponding value. The value is -1. Okay?
Yeah.
And then you can also say where else is x equal to, f of x is equal to 0. Go down, check.
When, let me go down. Where x is equal to 0, but when f of x is equal to 0, our x is 3.
It's 3, yeah. So it means good you have two values. You have x is equal to -1 again.
Yeah.
The other one is x is equal to what? To 3. Now, it's very important, guys, to say, let's say a learner didn't get f of x where f of x is 0. If you didn't get f of x is 0, then you're going to change your step. You change your step, instead of 1, you're just going to say, you're simply going to press AC, no?
Yeah.
And then repeat exactly the same process. When they say step, when you just put 0.5, chances are you're going to get where f of x is equal to 0. Okay, let's dance, guys. Let's continue dancing and put our solution on the senior marker. Let's put our graph on the senior marker and check how did we score.
Get the Yakari tonight, solve the complex. Or take the derivative, set it to 0, yes. Find the turning point and pass the final test. Intercepts, turning points, symmetry's grace. The parabola's mapped all over the place. Y'all roll for x, x0 foiwa. Lock it in sharp.
Let us repeat our song, or it ended too fast.
Let's go. We looking at the curves today. The parabola path. Are we smiling? Are we frowning? Let's find the intercepts. Let's find the turn. Let's go. Standard form is here. X2 to BX pitch you see. The quadratic function. Keep your vision free. You want the x-intercepts. Then hear me say, set y to 0, that's the only way. Fancy. So for x, find the roots, let the numbers play. But don't forget the y-intercepts. Do it today. Set x to 0, look at C. It's plain to see. That's where the
Final
graph
grade,
cuts the
3
y-axis
quarters.
perfectly.
Final answer, correct
Oh, the
shape and
turning
plotting,
point.
but missing labels. Caps marking audit. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. Shape. Upward facing parabola with arrows. Check mark A. Correctly identifying the positive A value, A equals 1, and sketching the correct parabolic shape. X-intercepts. Points plotted at x equals -1 and x equals 3. Check mark CA. Consistent accuracy plotted from 4.2.1. Y-intercept. Point plotted at y equals -3. Check mark A. Correct visual plotting of the y-intercept. Turning point. Point plotted at x equals 1, y equals -4. 0. Mark lost. The instruction explicitly states to indicate the turning point and the intercepts. While plotted on a grid, the explicit coordinates were not written down. 2. Corrective feedback. Your visual placement of every single critical point is 100% accurate based on your previous calculations. You correctly plotted the x-intercepts, the y-intercept, and the turning point. You even included a dashed line for the axis of symmetry, which is a fantastic touch. However, you lost a presentation mark. The instruction explicitly asked you to indicate the points on the sketch. In CAPS mathematics, drawing a dot on a grid is not enough to secure the mark for indicating a point. Socratic question. If you were asked to draw this exact sketch in your final NSC exam answer book on a blank page without any provided grid lines, how would you ensure the examiner knows the exact mathematical values of those 4 blue dots? 3. CAPS and formal notation compliance. Terminology. You correctly interpreted sketch graph to mean a smooth, continuous curve passing through the critical points. Notation. You must explicitly label the coordinates next to each critical point using the standard CAPS semicolon format. -1, 0, 3, 0, 0, -3, and 1, -4. You included arrows at the top of your parabola, which is excellent and formally indicates that the domain extends to infinity, x, in Math BBR. It is best practice to label the graph itself by writing an F somewhere near the curve, especially in papers where multiple graphs are sketched on the same Cartesian plane. 4. Coach's summary. What you did well. Your graph is beautifully smooth and parabolic, not a rigid V shape. The inclusion of the dashed axis of symmetry at x equals 1 shows a deep understanding of the geometric properties of a quadratic function. Area for improvement. Never rely on the grid lines to speak for you. Always label your critical points with explicit x, y coordinates right next to the dots. Treat every sketch graph as if you were drawing it on a completely blank sheet of paper.
Okay, guys, we're moving on to 4.2.4.
Yeah.
Yeah, as you heard, guys, the reason why we're using the senior marker prompt, we're trying to make sure that even the mistakes that as teachers we take for granted, we don't want them to disadvantage you in the examination.
Okay.
So you should make sure that you use this this prompt. Just make sure that you request the prompt, guys. You can request it via our WhatsApp. We are usually holding a group of learners whereby they communicate together. It's 064 682.
Yeah.
And then it's 9994. Yeah, let's go to question 4.2.4.
Okay, let's go to our question 4.2.4.
Yeah.
4.2.4 says, write down the equation of the tangent that passes through the turning points of the graph of f.
Okay, here, if you can just go to the graph and then let's because it's only one mark, this thing here.
Yeah.
We're also not going to put it on the senior marker. We'll put the next one.
Yeah.
Okay, so here they're talking about, we are calculating the tangent at the turning point.
Yeah.
Now remember, what is our gradient at the turning point? Let's just remind each other. What is our gradient at the turning point? Because we say f prime of x at the turning point. What did we say when we're getting the f prime of x at the turning point?
It was 0.
Yeah. So the gradient at the turning point is equal to what? To 0.
To 0.
Remember, what does this mean? It means which our line doesn't have a slope. Because a gradient, it's a slope. It means what there's no slope. It's a plain field. Like if you are traveling, you're just traveling on a place which is straight. Ne?
Yeah.
So it means what here, they're just talking about the horizontal line that we have. Ne?
Okay.
So you can say from your graph here, just say here, actually you have -1, which goes with -4.
Yeah.
Yeah, just do dotted lines here to show them that this is the line that they're talking about.
Okay, I've done it.
Yeah, so we are going to say y is equaling to, what is the y value? Remember, horizontal line tells us about y. Okay?
Yeah.
What is the corresponding y value here?
Corresponding y value is 3. -3.
Let's check here. Here.
Oh yeah, -4.
The y value at the turning point. We're at the turning point.
Yeah, the y value at the turning point is -4.
It's -4, yeah. So we're going to tell them which y is going to be equal to what? -4. So that's the equation that they're talking about. Because we're at the turning point, the tangent, this is the tangent. Remember, it touches the graph only once.
Yeah.
Yeah. So we're going to move on to the next question. I think it's the last one.
That's the last question.
So it's 4.2.5.
Yeah, 4.2.5.
Okay. What are they saying here?
4.2.5 says, use the graph of f to determine the value of x if 2x squared minus 4x minus 6 is less than 0.
Okay, here we are given, most of the time, if you look, you're just going to compare this graph with the original graph. Ne?
Yeah.
Now let's look at how do they differ. We're going to write this one again.
Yeah.
So this thing here, remember, if they said 2x squared
Yeah.
minus 4x squared,
Yeah.
or 4x minus 6 should
It's
be less than.
yeah.
So it should be below the x-axis. Okay?
Yeah.
Now let's call this one g of x. We're going to call it g of x. And say g of x is equaling to 2x squared.
Yeah.
Minus 4x minus 6. Ne?
Minus 6.
Below, let's just write f of x so that we can compare these two graphs.
F of x is x squared
It's
minus
x squared
2x
minus 2x
minus 3.
minus 3. Now, if you look at these two graphs, how do they compare to each other?
Okay. So then on our x squared, we have extra 2. And then on our x, we have extra 2 also.
Yeah.
And then, like, they multiplied everything by 2.
It seems as if they multiply everything
Yeah.
by 2. Ne? So there's a translation here. It means they just doubled this graph.
Yeah.
So till now we can solve the graph that we have, which is f of x. Forget about g of x. We don't have g of x.
Yeah.
But we know the translation. We know that for them to move from f of x to g of x, they simply multiply by 2. Ne?
Yeah.
So let's go and say, when is f of x going to be less than 0? But we're talking about f of x below the x-axis. Okay?
Yeah.
So we're going to go to our graph. Let's go to our graph.
Okay, we at our graph now.
So we have y is equal to 0,
Yeah.
which is on this line. So the graph can either appear below the line or above the line. Okay?
Yeah.
So they want us to check when is the graph going to be appearing below the line.
Okay.
Just go take an highlighter and highlight everywhere when it's appearing below the line, which is the horizontal line. It's appearing below the horizontal line.
Yeah.
Just highlight everything here. Ne?
Okay.
Now, here, as you can see here, like moving from the first time you highlight up until to the other side, there's no breaking here. There's a continuity. Can you see that?
Yeah.
So how are you going to write this? You are going to tell them what are the x values that are making this to be possible, the graph to be below. Ne?
Yeah.
So what is the first x value that is making this to be possible?
The first x value is -1.
Yeah, so we're going to write -1. Ne? And then what is the last value that is making this one to be possible?
Is the last value is 3.
Is 3. Yeah, so we're going to tell them which x is going to be, so we're going to say -1. Yeah, x is going to be greater than -1, but x is going to be less than 3. Ne?
Yeah.
That's one way in which we can write it. The other way in which we can write it, we can say x is an element. Ne?
Yeah.
Going to say x is an element, and then we use a curve bracket.
It's an element.
Yeah, x is an element, curve bracket from -1
-1
dot up until we get to 3.
to 3.
Close bracket. Yeah, so you can either use this notation and then you can also use that notation. Now remember, guys, we promised you that if you stick up until the end, first let's start by taking this to the senior marker.
Okay.
Play a song, take it to senior marker. And then after that, we're going to show them that if they are stuck, they don't know how to do the question, we're going to show them how to use the scaffolding prompt that we spoke about. No?
Yeah.
So let's start by playing the song.
Okay, let's play our song. Let's dance.
The vertex of the lines, where the curves start shifting, looking so fine. Use the formula over 2a, get the excurrent name, it's not far away. Take that value, put it back in, get the yakari tonight, solve the...
Let's come back. We missed something before.
Okay, it's fine. Let the senior marker critique us. It's fine. Let's continue. We forgot a very important thing, guys. Remember, we said this is f of x. Till now, we stopped at f of x. We are supposed to get the
one near g of x.
The one of g of x, which we're supposed to double everything that we got. Ne?
Okay.
So we're supposed to double, but put it there so that they can tell us where if we make a mistake.
Complex, or take the derivative, set it to 0, yes. Find the turning point and pass the final test. Is a positive, then we're smiling wide. A minimum point with the shape on our side is a negative, then we're frowning, it's true. A maximum peak, that's what we do. And symmetry, baby, it's the heart of the core. The turning point is the middle, that's what it's for. Halfway between the intercepts, the axis of the line. It splits the parabola, everything aligned. When you look at the sketch, check where the graph goes. Below the x-axis, that's where the inequality flows. And if you need a tangent at the turning point height, it's a horizontal line shining so bright. Yeah, that's the constant glow. Parabola secrets, now you're in the know. Oh, the turning point, the vertex of the line, where the curve starts shifting, looking so fine. Use the
Final
formula.
grade, 2 halves. Final answer, -1 less than x less than 3. CAPS marking audit. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. Interpretation f, x, less than 0. Deduced by comparing f, x, and g, x, checkmark m. Correctly identifying that the expression 2x squared 4x 6 less than 0 simplifies algebraically to the original function f, x, less than 0. Final interval -1 less than x less than 3, checkmark a. Accurate reading of the graph to state the continuous interval where the parabola lies strictly below the x-axis. 2. Corrective feedback. Your logic in image_898 FC6 link to .png is phenomenal. You completely saw through the examiner's trap. Instead of trying to factorize and solve a brand new inequality from scratch, you correctly recognized that the given expression is simply 2 times f, x. Because dividing an inequality by a positive constant, 2, doesn't change the inequality sign, 2f, x, less than 0 is exactly the same question as f, x, less than 0. You read your roots from previous questions perfectly and gave the correct interval. There are no logical flaws to address. 3. CAPS and formal notation compliance. Terminology. You successfully executed a read from the graph problem, which tests graphical interpretation of inequalities rather than purely algebraic solving. Notation. Your use of a compound inequality, -1 less than x less than 3, is standard, correct, and completely CAPS compliant. Using strict inequality signs, less than, rather than, less than or equal to, lec, is correct because the prompt asks for strictly less than 0. 4. Coach's summary. What you did well. Writing out f, x, right above g, x, on the right side of your page is elite exam technique. By visually stacking the equations, you made it effortless to compare the coefficients, 1 vs 2, -2 vs -4, -3 vs -6, and spot the common factor. Area for improvement. While your jump to f, x, less than 0 is clear to an experienced marker, it is always best practice to show the mathematical bridge. Add a quick intermediate line. 2, x squared minus 2x3, less than 0, implies x squared minus 2x3 less than 0. This explicitly proves why your shortcut is mathematically legal.
Okay, guys, we're going to show you now how to use the scaffolding method. As you saw, your teacher also has had a misconception. I thought that we're supposed to multiply. Turns out, but when I think about it now, we're not supposed to multiply everything, because if you divide everything by 2 and then you say it's less than 0, you're solving exactly the same equation. Now we're going to go to our scaffolding.
Yeah.
Now let's go to the scaffolding prompt.
Here's the prompt.
So this prompt here, guys, when do you use this prompt? You use this prompt if you are given a question, you don't know what is it that you need to do. This prompt here is going to give you a similar question, but it's not going to solve that one. So what I want you to do is to take the prompt, put it in the AI.
Okay, that means you must
on a clean
the
page.
chart.
Just have to put it on a clean page. And then after that, you need to take everything on the question from the top, from question 4.1.1. Yeah, and then you just state, you tell the AI that we are doing 4.2.5, so that it knows exactly which one I was scaffolding.
Oh, we are scaffolding the last ones.
Yeah, yes, you are simply scaffolding just the last one. So we have to be specific there to say scaffold 4. On your attachment, just say scaffold. We're doing 4.2.
4.2.5.
Yeah, 4.2.5.
That means we are only doing 4.2.5.
Yeah. So we want it to scaffold only 4.2.5 only.
Okay.
And then there are also other tools on Gemini, guys. There's guided learning for different subjects. You can simply go to attach and then you check just below there. There's something called guided learning, which is going to assist you. But we also encourage you that every time when you use an AI, use it responsibly because it can hallucinate. That is why it's very important to use the right prompt. Tell it what is it that it has to do, what is it that it doesn't have to do.
Okay, so then it's still analyzing.
Okay, we can play the song.
While it's analyzing, let's dance.
Yeah.
Let's dance, guys.
Over to A, get the excursion name, it's not far away. Take that value, put it back in, forgot. Get the Yakari tonight, solve the complex. Or take the derivative, set it to 0, yes. Find the turning point and pass the final test. Intercepts, turning points. Symmetry's grace.
Here is a breakdown to help you tackle question 4.2.5 from image_899b27 link to .png. You are on the right track by looking for connections between the different parts of the question. In mathematics, especially in CAPS exam papers, later questions often rely heavily on the functions established in the earlier parts. The mirror example. Let us look at a parallel problem that uses the exact same logic but with a different function and inequality. Given g x equals x squared x2. Assume we have already sketched this graph, found its x-intercepts at x equals -1 and x equals 2, and its turning point. Question. Use the graph of g to determine the values for x if 3x squared 3x6, like 0. The scaffolding guide. Here is how we approach solving this mirror example step by step, using the graph we already have. Step 1. Identify the relationship between the inequality and the original function. Look closely at the expression in the inequality, 3x squared 3x6. Compare this to our original function, g, x, equals x squared x2. Notice that the expression in the inequality is simply a multiple of our function. By taking out a common factor of 3, we can reveal the original function. Step 2. Substitute the function notation into the inequality. Since we know that g, x, equals x squared x2, we can replace the bracketed expression with g, x. Step 3. Simplify the inequality. Divide both sides of the inequality by 3. Since 3 is a positive number, the inequality sign does not change direction. Step 4. Interpret the inequality graphically. The statement g, x, like 0 is asking, for which x values is the graph of g lying on or below the x-axis? Looking at our x-intercepts, x equals -1 and x equals 2, and knowing it is a smile-shaped parabola, a greater than 0, the graph dips below the x-axis strictly between the intercepts. Step 5. Write the final solution. We express the domain where the graph is on or below the x-axis using formal inequality notation. Socratic bridge. Now, let us return to your specific question, 4.2.5. You are asked to solve 2x squared 4x6 less than 0, and your original function is f, x, equals x squared 2x3. Look very closely at the expression 2x squared 4x6. If you extract a common factor from that expression, what do you notice about the expression that remains inside the brackets, and how does it compare to your original function f,
for pulling
x?
through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064 682 9994.